All right, today we are going to do something really cool. We're not just talking about AI theory, we are building an AI completely from scratch. The mission? To create our very own custom AI assistant that can write Python code for us. Let's get right into it. So here's our game plan. First, we're going to talk about why on earth we'd train a model from scratch. Then, we'll hunt down the perfect data. After that, we'll get it all prepped for the AI, actually build our code helper, and then the fun part. We'll see if it actually works. You know the feeling, right? If you've ever done any kind of data science work in Python, you've been there. You're deep in the zone, everything's flowing, and then bam, you have to stop and Google the exact syntax for a matplotlib chart you've made a million times. It just completely kills your momentum. Well, what if we didn't have to? That's what this is all about. We're going to build our own personal, specialized little coding assistant. Think of it like a mini co-pilot that knows exactly the kind of code we write every single day. That's the dream. Okay, so first things first. Why are we going through all this trouble? I mean, most people just grab a huge pre-trained model and fine-tune it. Why are we doing this the hard way, starting from a blank slate? Well, here's the deal. Those big pre-trained models are amazing generalists. They've learned from, the entire internet. But we don't need a generalist. We need a specialist. We need a model that is an absolute expert in one thing: Python data science code. By training from scratch on a super focused data set, we can build that expertise from the ground up. And that leads us to the single most important ingredient in this whole recipe: the data. You've heard it a million times, but it's true. An AI model is only as good as the data it's trained on. So we have to find the perfect stuff. Our starting point is this absolutely massive data set from GitHub called CodeParrot. And when I say massive, I mean it. We are talking about 180 gigabytes of code. That's something like 20 million different Python files. It's just way, way too much for what we need. Now, we're not going to download all 180 gigs. That would be insane. Here's where we get clever. We stream the dataset, which means we look at it file by file without saving it. And as we're streaming, we scan each one for keywords we care about, like pandas or scikit-learn. If a file has our keywords, we keep it. If not, we toss it. And check out the result of that filtering. We went from 180 gigabytes all the way down to just 6. That's only 3% of the original data. But what's left is this incredibly dense, super relevant collection of 600,000 Python scripts that are perfect for our code helper. Okay, so we've got our specialized data. Awesome. But you can't just dump raw code into an AI model and hope for the best. We've got to prepare it first. It's kind of like doing all the chopping and prep work before you actually start cooking a meal. This part is absolutely crucial. And the first step of that prep work is something called tokenization. All this really means is that we break all that code down into tiny little pieces, or tokens, and then turn them into numbers. See, a model doesn't see words like import pandas as PD, it just sees a sequence of numbers that represent those words and symbols. And this is exactly the kind of stuff that's inside our 6 gigabyte dataset. It's just full of these common lines, the imports, the functions, all the patterns we want our new AI assistant to learn like the back of its hand. So once everything is tokenized, we do one more thing. We chop up all those long scripts into perfectly uniform, bite-sized pieces, or chunks of 128 tokens each. And this is where the magic happens. That one step transforms our 600,000 scripts into a mind-boggling 16.7 million individual training examples for the model to learn from. All right, our data's prepped, it's chunked, it's ready to go. Now we get to the really fun part: actually designing the brain of our AI and kicking off the training. We're going to use the GPT-2 architecture for our model, a relatively small version with 124 million parameters. You can think of those parameters as tiny little knobs and dials that the model will tune as it learns. But the really key thing here is that we are initializing this model totally from scratch. It knows nothing to begin with. It's a clean slate, which is why our specialized data is so important. Now, when you actually go to train the thing, you have a couple of options. You could use a high-level tool like the Trainer API, which is super simple and powerful for most standard cases. Or if you're a control freak and you want to customize every little detail, you can use something like Accelerate. It's really just the classic trade-off. Do you want convenience or do you want total control? So, the training process itself can take hours, even days. But once it's finally done, we get to the moment of truth. After all that work, the filtering, the tokenizing, the training, did it actually work? Let's find out. We'll kick things off with a pretty simple and common request. We're just going to give our new model a comment as a prompt. We're asking it to create a scatter plot. This is a basic task you do with the matplotlib library. And boom, look at that. It's perfect. It knows it needs to import matplotlib, and it knows the correct function is plt.scatter. It's a small win for sure, but it proves the basic concept is working. Okay, let's turn up the heat a little bit. For our next test, we'll ask for something more complex from the scikit-learn library, a machine learning workhorse. Let's see if it can handle this. Yes, it nailed it. It correctly imports the random forest classifier from exactly the right place and even initializes the model for us. This is huge. It shows our model didn't just memorize random bits of code. It actually learned the specific syntax and patterns of the Python data science world. So let's just recap what we did here. We started with this gigantic, messy 180 gigabyte dataset. We cleverly filtered it down to a lean, mean 6 gigabyte corpus. We processed that data into millions upon millions of training samples, built a model completely from zero, and what we got at the end is a real, working, custom AI code assistant. And that really just leaves you with one final thought. This whole process, this whole idea, it's not just for code, right? You could do this for legal documents, for scientific papers, for musical compositions, for anything. If we can build a specialized AI this powerful this quickly, it just opens up a whole universe of possibilities. The only real question left is, what are you going to build?